Okay, now you're tasked with the job of writing a rule. So remember when we were talking about translations and you started with an X and Y, and then the rule said we're going to go 4 to the left, and for the Y's, we're going to go down 1. That's a rule. Or when we had X and Y and we rotated around 180 around the origin, about the origin, the rule says that you just multiply both the X and the Y by -1. All right, so that's what it means by write a rule. So if you can look at this, it looks like that's a reflection over the y-axis. And if you don't remember what we did, what you're going to do, here's a tip. It doesn't usually work very well when it's sitting on an axis, so either the x or y is 0, but let's take a positive original s. So we went over 1 to -3, up 4. Now let's look at s prime. So this is s, this is s prime. 1, 2, 3. +3. Well, look what's changed. What's changed are the x's, which means this is a reflection. Remember, when it's a reflection over the y-axis, the x's change, and that makes sense. You start here, and then you go to here. It's the x's that are changing. The heights are the same. So reflecting over the y-axis, the rule is the x's. So we multiplied. So the rule I guess would be this: -x, y. All right. Let's look at number 16. Let's see. I'm going to focus my attention on K and K prime. Well, look at what's happening there. They look like they are reflecting over, well, this line right here is where y, it's a horizontal line where y is 1. So it's reflecting over y is equal to 1. Now let's look at the k. So that original k, oh, k is not going to be a good one to look at. Let's look at m, because it's 0, 0, so you won't be able to tell what you did. So let's look at m, and then m prime. Let's see if we can make up a rule. So m is 4, m prime is 4, -2. Yeah, this one is going to be a little bit tougher to come up with a rule just by eyeballing it. Okay, so what I meant by that, there's not going to be a rule like this. You actually do just eyeball it. So what that means is where the line of reflection is, we went up where the m is. Let's focus on the m. We went up 1, 2, 3. So that distance is 3 away. So you're going to go 3 away in the other direction. So this is 1 plus 3. This is 1 subtract 3. All right, that's it for this one. For writing, oh no, I'm going to keep going. All right, because this is just the regular week 7 video. Coordinate points. So if you're reflecting something across the x-axis, it's the heights that are changing. So if you start off with xy, it's the y's that get multiplied by -1. So if c is -5, 1, then c prime will be -5, -1. Because only the y's, because we're going to reflect, so c prime, and let's see if that makes sense. Here's the x-axis, so here's the point, the line of reflection. We went up 1, we're going to go down 1. Yeah, that makes sense. So this is c prime, all right? So d prime, so if d is -1, -1, we're going to multiply the y value by -1, so we change that sign. So -1, +1. And that also makes sense because from the reflection line, we're 1 away from the x-axis. All right, so let's go with e prime. So this is at -4, -4. But we multiply the y value by -1, so that will be -4, +4. So this is e prime. And then finally, I probably should have left some room to put b prime up there, but I didn't, so I'll just write it down here. B prime is -5, -3. So we multiply the y value, so -5, +3, and this is b prime. Yeah, that shape, if you were to fold it up over that red dashed line, the x-axis, that shape would sit on top of each other. All right, let's keep going. The distance, we've practiced this a lot. I have an individual video on that. Because we're given 2 points, you're going to take the distance of the x's, so x2 subtract x1, so 1 subtract -2, and then you're going to take the distance of the y's, you're going to square each of those, so 3 subtract -1. Then remember, subtracting and negatives like adding. So now what you have in here is 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16. Add those together, you get 25. Well, the square root of 25 is 5. So 5 units. That's the distance between those 2 points. Okay, let's go on. Midpoint. It's when you take the average of the x's and the y's. So you add the x's and the y, x's together, divide by 2. Add the y's together, divide by 2. So the midpoint is here are our x's. 2 plus 2. Well, 2 plus 2 is 4. 4 divided 2 is 2. Then our 2 y's. negative 1 plus negative 2. Well, that's negative 3 divide 2, so you could put negative 3 over 2. If you use the divide button, you get negative 1.5, and I will accept either. But if we're plotting points, it's probably easier to use the negative 1.5. So typically on these tasks, putting in decimal form is great. Okay, now when you have an endpoint and the midpoint, what you have to find is the new endpoint. So the x2, y2. Well, this is halfway between. So here is if you don't want to do it the formula method, do this. What's the distance between 8 and 6? That distance is 2, and you went 2 down. Go 2 down more, and you're going to end up at 4. And now let's look at the y. We start here at 7. We go down to 1. That distance is 6. So go down 6. You'd end up a negative 5. Now, having said that, let's do the formula method to make sure that that works. That is a really good way to do that, though, visually, if you want to find the endpoint when you know one of the endpoints, when you know the endpoint and the midpoint. So let's go ahead and check to see if those work. So we're going to find the midpoint. We're going to pretend we don't know it. So we're going to add 8 and 4 together. We're going to divide that by 2. And then we're going to add 7 and negative 5. We're going to divide that by 2. Well, 8 plus 4 is 12. 12 divided by 2 is 6. Excellent. 7 plus negative 5 is 2. 2 divided 2 is 1. So this visual way, from 8 down to 6, we subtracted 2. So then from 6 to 4, we subtract 2. And then from 7 to 1, we subtracted 6. So from 1 to negative 5, we subtracted 6. So that is going to be kind of a cool way to do that if the formula method doesn't work very well for you. Okay. Simplify. This is an index of 2. That's a square root. So we want all of those things to be perfect squares. Well, b to the 4th is a perfect square because the square root of 4 is 2. So right there, we can pull out a b squared. So I'm going to put a negative 9 over here. I'm going to put the a to the 5th. So let me go ahead and write some of this stuff. A to the 5th I can write as a squared times a squared times a to the 1st, and then we've got a times c. So these things are going to end up staying because when you have things to the first power, well, they don't have a perfect square. But this a squared and this a squared, they both come out, and now you've got a times a, which is a squared, and now we've got 405. We'll see how that ends in 5. So this is going to be, looks like 4 times 80, 5 times 81. 81 is 9 squared. So 5 times 9 squared. And then look it. A 9 comes out. And what we have left that stays under the radical is 5 times a times c, close the parentheses. Now you have negative 9 times 9, so that's negative 81. a times a is a squared, and then b squared is just b squared. All right. You can subtract as long as the radicals are the same, and they are. Well, 2 root 3 subtract 2 root 3 equals 0. These are not the same, so we're going to rewrite this as subtract 2. Well, root 45 can be rewritten as 9 times 5, and then a 3 comes out. So I'm going to put 9 times 5, factors of 45. I'm going to bring a 3 out. So that is now subtract root 5, close parentheses. So now we have negative 2 root 5. Subtract, well, these radicals are the same now. So we know a root 5 will be part of the answer. Negative 2 subtract 6 is negative 8. All right. Solving for extraneous solutions. Well, we want to get this p by itself, but it's under the radical sign. So we have to square that radical to get rid of it. But if we square that side, we have to square both sides. Remember the teeter-totter. To keep it balanced, if you do something to this side, you have to do something to that side. So now we have p subtract 4 is equal to 4. Well, we want to get the p by itself, so we will add 4. P is equal to 8, but then you have to check to see if that solution works. So 8 subtract 4 is equal to 2. Well, 8 subtract 4 is 4. Yep, the square root of 4 does equal 2. So that answer checks out. And on this one, well, that's pretty easy. If you square both sides, you get k is equal to 9. And then when you do the check, the square root of 9 does equal 3. So that one's really easy. Remember, you have to check each time because once in a while, you'll have what's called an extraneous solution. That means that let's say we got x is equal to 2. Well, or k is equal to 2. Does the square root of 2 equal 3? No. That would be called an extraneous solution. All right, that's it for this week.